Good afternoon, everybody. I'm Dan Hewitt, and welcome to NASA's Johnson Space Center here in Houston, Texas. 2 spacewalks on the horizon for the crew of Expedition 45, so we're here to learn a little bit more about them today. Joining me here up on the desk to talk to you is Kenny Todd, the International Space Station Operations Integration Manager. We have Mike Lammers, the lead flight director for Increment 45. Then our 2 lead spacewalk officers, Grant Slusser for EVA 32 and Art Thomason for EVA 33. As usual, we're going to hear from each of them first with their opening remarks, and then we'll open it up for questions here in the room and on the phone bridge. Just a reminder, if you're on the phone bridge, press *1 to be able to ask a question. So let's go ahead and kick this off. Kenny, why don't you start?
Thanks, Dan. Let's see. Good afternoon, everyone. First of all, I'll start off by saying that our Increment 45 crew is doing extremely well on orbit. Scott and Mikhail are today celebrating their 208th day on board the International Space Station. Kjell, Kimia, and Oleg are 91 days in to their increment, and Sergey, who arrived back in September, is on orbit today for his 51st or 50th day. Guys are doing great. No major issues on board. We're coming up on a pretty significant time for the program in that on the 2nd of November, we're, as a program, going to celebrate 15 years of human presence on orbit, which when you think about what you were doing 15 years ago, it's a pretty impressive feat that we've been managed to keep people off the planet for 15 years straight. So it's anyway, it's a great milestone for this program, and so we're excited that we're about to be able to celebrate that important feat. As far as this year, we've had some challenges this year, primarily trying to get cargo to orbit. I don't think that's a surprise to anybody. I think what might surprise you a little bit is in the midst of all that, we've managed to maintain a pretty steady and balanced science program. Obviously, with our 1-year crew members on board, doing a lot of what we've termed the human research program has been very successful. That's something we've done across both segments, the USOS as well as the Russian segment, done a lot of good work on both sides. In addition to that, we're continuing to do material sciences, biological sciences. We're continuing to work on earth science type of projects, and so and as much as we can, doing educational type payloads as well. So a lot of good things still going on. It's a variety of different activities, and probably one of the most important objectives we had laid out for this year was to do some reconfigurations as part of getting ready for some of our commercial crew vehicles in the next couple of years. And so we'd set some milestones forward for ourselves to try to accomplish this year. And while we haven't been able to do everything we hoped we would, just because some of that cargo didn't get to orbit, we did have a significant amount of cargo that was on orbit that allowed us to move forward with those tasks. And so one of our primary goals was to get the Node 1 Nadir location ready for a visiting vehicle. And just this past week, we were able to check that box, and now we're ready to receive a vehicle there. And in fact, hopefully in early December, we'll welcome the Cygnus to that Node 1 Nadir port. So looking forward a little bit, obviously the flight program that we had in January is not the flight program that we have today in terms of our visiting vehicles, and so we've been doing a lot of work trying to work with the providers and figure out where the best opportunities for them are going to be based on their recovery efforts for their launchers. And now that we've got that squared away, it's looking like this winter is going to be an extremely busy time for the folks on the ground and the crew on orbit. If you look over the next couple of months, starting around mid-November to the end of the year, we're going to get 3 visiting vehicles coming to the station. We're going to take one of the vehicles there that's currently there and rotate it to another port, and then that same vehicle will return about 8 or 9 days later, bringing a crew home. So a lot going on relative to visiting vehicle traffic between now and the end of the year. And then just after we turn the corner into the new year, if everything holds to schedule, we'll be welcoming the SpaceX Dragon back on board again, and Those discussions are still ongoing in terms of exactly what date we're talking about, but certainly January is in our sights right now. So everything as far as we know is progressing down that path. That kind of brings us to why we're here today. When I talked to you guys earlier this year, I kind of laid out a plan based on a lot of the reconfiguration work that said we would do about 7 EVAs this year. Obviously, we weren't able to do that. We had to defer some of those tasks. We did get 3 behind us earlier this year. And the fact of the matter is that we have what I would consider a backlog of EVA tasks, things that we've been wanting to accomplish on the outside of station, and basically been carrying those tasks as things that we'd put in the mix when we could. Given that we now know where the visiting vehicle traffic is going to be, we looked for a window, if you will, an opportunity to jump in with a couple of EVAs, and we found that window here in the end of October, 1st of November time frame. And so we got together as a program, looked at that EVA backlog list, determined that work that priority-wise was the most important to go ahead and get behind us, the work that we could get done with the hardware that we had on orbit. And so that's what we're going to do here starting next week. So none of the hardware is extremely critical to the commercial crew effort. We're going to do a little bit of work there, but by and large, this is a lot of work that's going to be important to the long-term sustaining of space station, and so that's what we'll set our goal on here for the next couple of EVAs. As far as the EVA preps go, crew has been doing that work. Mike will talk a little bit to you about the specifics of what we're going to be doing on these EVAs. Suits are in good shape. Crew is certainly on the right path, and next Monday we'll do, at our mission management team, we'll do our final go, no go. And all indicators are at this point that we'll be ready to go for this first EVA. So with that, I think I'll turn it over to Mike and let him talk to you about the specific list of things that we're going to try to get accomplished with these EVAs.
All right. Thank you, Kenny. Again, I'm Mike Lammers. I'm the Increment 45 lead flight director. I'm the guy that's managing the day-to-day ops of the crew, and we'll talk about U.S. Spacewalks 32 and 33. U.S. Spacewalk 32 is scheduled for October 28th, and U.S. Spacewalk 33 is planned for November 6th. Each spacewalk is planned for our standard 6.5 hours of time outside the airlock. Both spacewalks will take place in U.S. suits with preparation and egress from the U.S. Quest airlock. As I mentioned, we've got 2 EVAs planned. The theme is setting ourselves up for a very busy 2016, getting ready for some of the vehicles that Kenny mentioned are coming up, and sort of taking care of this backlog of EVA work. Over the past couple of weeks, along with the ongoing science program, as well as doing that Node 1 Nadir work, the crew's been prepping the suits and studying procedures for the EVA. In fact, just this afternoon when I left, they were wrapping up their dry run where they get into the suits as a kind of a final prep before the EVAs. Interesting thing about ISS EVAs is a lot of the kind of the training and the preparation and familiarity of the tasks actually happens after the crew is launched, and this was no exception. These 2 EVAs, a lot of the content was finalized and put together after these guys were in space. So along with the execution that Grant and Art will talk about, and kind of laying out the technical parts of the EVA, a big component of that is actually training the crew on orbit and laying that in along with all the other things that they do on orbit to keep them busy. So first, let's just again introduce our spacewalkers. For both EVAs, Scott Kelly and Kjell Lindgren from NASA will be our EV crew. And then from the Japanese Space Agency, Kimya Yui is going to be the Ivy crew member, who actually has a very important role in the time leading up to before the crew goes out the door. Kimya will be orchestrating suiting them up in the pre-breathe protocol that we do to get them ready to go EVA in the environment of the suit. Also, we'll have some assistance from Sergei Volkov of the Russian Space Agency. Sergei will be helping with the suit up. An extra pair of hands is always helpful in the airlock. I'll mention, going back to Scott and Kjell, This is actually for both of Scott and Kjell. This is their first EVA. They're both very excited. In fact, I talked to Kjell on the phone last night, and we chatted about it for a while. Scott, in particular, has had a long history here at NASA, over almost 20 years as an astronaut, as a shuttle commander, station commander, both on his last flight and this one. And of course, he's a NASA member of the one-year crew, so it's particularly nice to see him have this opportunity. Going on to the specifics of each EVA, for EVA number 32, we have individual flight directors that are paired with the EVA officers that are going to talk to you in a minute. For 32, Greg Whitney will be the flight director, and the lead EVA officer is Grant, sitting here to my left, Grant Slusser. EVA 32 is also what we've been calling the ISS Upgrades EVA, and that's the EVA that we've planned for Wednesday, October 28th. As Kenny mentioned, over the next several months, ISS will be reconfigured to provide, actually next several years, ISS will be configured to provide 2 new docking ports on the U.S. segment for commercial crew vehicles. This EVA will take care of laying power cables to support pressurized mating adapter number 3. And that, as you can see in the graphic there, that pressurized mating adapter is eventually going to be moved from where it is now on node 3 to the zenith port of node 2. And we'll lay out the power cables to support that. It'll be relocated robotically in the near future. We'll also lay some power cables to support what will eventually attach to PMA-3, and that's called the International Docking Adapter. And that's flown up on SpaceX vehicles. And that will become actually the secondary docking port for the commercial crew vehicles. The primary docking port, you can see it right there, will be IDA-2 on the forward end of PMA-2 where the orbiter used to dock. While we're out there, besides laying those cables, we'll also take care of removing a thermal cover on a spare main bus switching unit, or an MBSU. There are 4 of these in our station electrical system, and it allows us to basically route power between the various power channels we have on board. By taking that thermal cover off, we'll be able to manipulate that and remove it from where it is on the logistics carrier with our robotic assets on orbit, and eventually bring it back inside of ISS, and we can perform maintenance and repair on it. We'll also install a thermal cover on the alpha magnetic spectrometer, or AMS. That'll help prolong its life. AMS is kind of our signature external payload, and the interesting note about AMS is that it was delivered on STS-134 as the primary payload, which was commanded by Scott's brother Mark Kelly in May 2011. Last thing we'll do on this EVA is we're going to do a lubrication on the end effector of the space station robotic arm. Of course, the end effector is the part that actually grabs onto things, and there's 2 end effectors on the arm. One's on either end. Typically, one end is holding on to ISS, and then the other end is capture, for example, Dragon vehicles. We actually lubricated one end of that arm, the end effector on the arm, in February in EVA number 30, and this is just a duplication of that effort with the other lead on the other side of the arm. Moving on to EVA 33, the lead flight director for EVA 33 will be Scott Stover, and the lead EVA officer is Art Thomason, and you see a graphic of Scott there. Brief overview of EVA 33. We call EVA 33 the return to original configuration of the P6 truss. We also refer to it as RTOC if you hear one of us say that word, and that's planned for November 6th. Just to give you a little bit of an overview, there are 8 power channels on ISS, and they're associated with the large solar arrays that are on either end of the truss. And each one of those 8 power channels has its own small ammonia cooling system with obviously an ammonia working fluid, pump package, and a radiator. And it's mainly there to cool batteries and avionics outboard of the gimbals that actually rotate those solar arrays. We have a little bit of a history of the system that's out on the port side on the P6 truss. It had a very slow leak that we'd been tracking for a number of years, and in our telemetry it actually started to worsen a little bit as we were monitoring it in 2012. It's not always easy to isolate a leak, and it's a little bit more complex when you're talking about hardware that's outside. But typically what you do is you try to isolate individual parts of the system, and we started doing that with an EVA on November 1st, 2012. And what we did is we bypassed part of the system by moving its ammonia lines, connecting it to an older system that happened to have been in the P6 truss from assembly. And we also deployed a spare radiator that's called the ticker, or the trailing thermal control radiator. The trailing sort of comes from that whole truss used to be up on the zenith side of ISS early in assembly, and that was what was facing the aft, and that's where the trailing comes from. By deploying that radiator, it allowed us to, there's some thought that perhaps the leak was in the original radiator, so we sort of like troubleshooting a home air conditioning system. We put the ammonia through that new radiator to see if that was the problem. Also, by connecting things to the older system, we allowed more ammonia to go in that helped us feed the leak a little bit and buy time. And as it turns out, that particular EVA didn't stop the leak, but it did buy us some more time. The leak did get worse, and actually after the crew reported seeing flakes of ammonia outside the window, we fairly rapidly and in a nice effort did a final EVA on May 11th, 2013, which replaced the pump package in that system. After that occurred, telemetry indicates that system's now leak tight, and what we'd like to do is get back to the original configuration. A big reason of that is that ticker array happens to be one of our the ticker radiator happens to be our spare radiator, and by having it deployed, it exposes it to micrometeoroid debris and possibly causing another leak that would be equally difficult to troubleshoot. So what we'd like to do is retract that radiator, restore the cooling system to a normal configuration, top off the ammonia to replace what was leaked off, and that's the goal of the second EVA. So with that, I'll pass off to Grant Slusser, and he'll give us a detailed look at what we're doing for EVA 32, and then Art will talk about EVA 33.
All right, thanks, Mike. I'm Grant Slusser, lead EVA, first-time EVA officer for EVA 32, or upgrades. I've been blessed to have a great team working with me with Sandy Moore, Brian Mader, Reagan Cheney, Goose Gustad, as well as Greg Whitney, Tracy Codwell, and just a slew of team that's helped me get this way. We had a pretty quick development on this EVA within the last 3 months. We put this EVA together, get the crew trained and ready to go on board. First time. I'd like to introduce the crew. Mike's already said that Scott and Kjell will be doing both EVAs. On my EVA, Scott will be wearing the red stripes as EV1, and Kjell will be wearing the plain white stripes as EV2. So they'll go out, Scott first and Kjell second, come back in. Kjell first and Scott second on our EVA. As Mike mentioned, we're doing a lot of EVA work just to get ahead. We're doing the AMS blanket, the MBSU MLI. We're sending both crew out to that area at the first of the EVA. We're coming back to the center of the stack, doing lead lube and IDA cable routing. After that, we've got some MPV out on node 3, PMA3, and if you don't mind, I'll go ahead and go to the video and discuss the video. All right, like I say, Scott will come out first at the airlock. We'll hand out the bags. Once Scott's out, Kjell will start handing out all the bags. This is to keep us from going back in to the airlock midway through the EVA. So we'll head out. Kjell will come out shortly. Scott's going to carry the MLI bag that we're going to put the MBSU MLI on, and Kjell's going to take care of the lead lube equipment that's going to go stage at the lead lube area. So Kjell will grab the BLT, or ball screw lubricating tool, from Scott and move it over to ESP2 where he's going to pick up an APFR. So Scott's going to head out. We're both heading to the starboard truss on the forward side out to almost the Sarge. So we're going to go up the Cedar Spur with Scott. He's going to translate out all the way to the end to Sarge area, where he's going to go up on the Sarge handrail to the logistics carrier module where MBSU is stowed. As we get there, he's going to take the MLI bag that he has and stow it on the bag. While he's doing that, Kjell's going to be working to get an APFR off the ESP2 and drop off the Lee Lube tools and bring the APFR out to AMS. When Scott's got that bag deployed, he's going to start removing the MLI or off the MBSU. He's going to start tying down what we call the skirt, which is a lower portion of the MLI. It has 8 tabs on the front. We're going to tie 4 down to one handrail, 4 down to the other. And near the electric connections, we're going to tie that side of the MLI skirt down. After we get it tied down, we're going to move to the aft side where there are 2 bolts that remove the MBSU MLI. After we've got it there, Scott's going to stuff it back in the bag and allow Kjell to bring it back inside. Here's Kjell going to the APFR area where he's going to drop off the Lee Lube tools and grab the APFR from that area and take it out to AMS. He's pretty much going to go the same route. He's going to go up to the forward truss and out to the seated cart area, up the AMS, and then deploy the APFR. Because of the translation holds on the AMS, we're taking the APFR out there for additional handholds and translation ports. Once he gets there, we'll take some pictures and install a small wedge over one of the radiators. It's going to slide into an area, and I have a video shortly, slide into the area between the 2 radiators and secure there. And here is how we're sliding it over the main radiator, and then we're grappling with a wire tie to tie it down. Once we get it secured, then the MLI will pop out like a small tent, filling the wedge in between the 2 radiators to protect the radiators. Once we're there, Kjell's going to work back to put on the big blanket. You'll see it here. This is point A, the first tie down he does. And you saw the blanket kind of pop in. It's not going to happen that quick on orbit. We're going to have to go down to a second strap, put that strap around AMS, and then work to a third and a fourth strap. So this third strap, it's very possible we'll get into the APFR and tie that strap around a strut right there by the wedge, and then he'll move aft and zenith to protect the final area of staging there. Once we do that, it does have a grounding pin on it that we'll apply, and once the grounding pin's installed, we're complete with both AMS small blanket and large blanket to protect their pumps. And here's an MBL video just showing the actual size of the blanket as it's deployed. He's working down what would have been the nadir part of the previous photo. So after we get the 2 blankets installed and the MBSU MLI removed, Kjell and Scott will work together to bring both the APFR and the MBSU MLI back. Kjell's going to grab the bag and go back completely the same way he came to the airlock, where he'll stow that bag outside the airlock and grab a cable bag. The cable bag is the one Mike spoke of with the PMA IDA cables in it. Again, stowing most of the bags on the outside of the airlock so we don't have to ingress. Scott will come back with the APFR that we grabbed from the AMS area and install it at ESP2 to perform the lead lubing. The arm will be presented there and move in close to Scott. We have some photos of that a little bit later. Kjell will grab that cable bag and go nadir underneath the lab up to the port side, where we'll deploy the bag. While he's doing that, we're giving him kind of good reference hand holds of where the cable is going to be tied to or deployed to. After he installs the cable bag, he's going to pull out the forward portion of the cable and temporarily stow it on a handrail. That's going to give us a good point where the center line of the cable is. We'll secure it at the center point and then grab the aft portion of the cable out of the bag and route it zenith on the lab over to the node where we'll connect the power cables up. So the orange cable is the first one we'll do. It is data for both IDA and PMA3, so we'll route it, connect it to the data port, and as we move back forward, we'll push all the cable slack forward, make sure we have enough when we install the IDA. Once he's back at the center point, he's going to move that directly forward on station over to node 2, and then up to the CBM area where we're going to deploy those 2 cables, tucking it out of the way of any pedal deployments on the CBM. Once he's complete with the orange cable or the data cable, we're going to go back and get the power cable, which we call the purple-white cable. He'll do the exact same thing where he stows the forward half of the cable out and then routes the aft portion of the cable back towards node 1, where we're going to plug it in again, nadir of node 1. As he's done with that, he'll move back forward, pushing the cable forward, getting all the slack out, and back to the center point. At this point, Kjell's going to break out of the cables and go work on the MPV. And while we're doing that, Scott's already back at the lee, working on the lubricating lee B. Here's a good shot of lee A that was previously lubricated. As we bring it in, you can see the centralizing ball screw right in the middle and the 4 latches. We're going to label those latches around clockwise just so we have a reference point, 1, 2, 3, and 4. And each side has an A and a B side, just so we can talk to Scott while we're greasing up the equalization brackets and the rollers. There's 2 equalization brackets and 4 rollers on each latch. You can see them when they're extended. So that's what we're going to grease. When it's retracted, we'll also grease the linear bearing tracks on each side of the latch. Here you can see a demonstration of the centralizing ball screw using the ball screw lubricating tool, or the BLT as we call it. We got grease on it, address it to the screw, and push it forward. And this makes sure that we have the grease in the grooves that we're looking at. Now this one's an easy ball screw, so we're going to attack it first because it's very visible. The other ones are blind mate. You can look here and see just an indication that there is grease that's moved by seeing the ridges in the grease. Here's the blind mate connector on any one of the latches. They're all pretty much the same. We're going to go in through a small cutout near the electrical connections, go back about 12 inches. As he inserts it, he's trying to miss any electronics or bolts that are in there. Once we get it into the depth, which is the tape that's on the PLT, we're going to rotate the cradle in towards the ball screw. Once it's there, then we'll apply grease to the ball screw that's in the back of the latches. And of course, this is very easy to see on our trainer, but really hard to see in space. So after that, we're going to go after those linear bearing tracks, grease both sides of each linear bearing track to get grease, and as the latch moves forward, it'll pull the grease back through the whole linear bearing track. After that, we're going to go to the equalization brackets. Both inboard and outboard, there are 4 points for the equalization brackets and 4 rollers on each side, A side and B side. There's 2 each. So we'll attack those equalization brackets and rollers. And after that, we're complete, taking photos and getting out of here. And I think the next video you'll see is the arm moving in. And if you look closely on that, you can see the dots of grease that Terry applied on EV830. So on each latch, you can see grease dropped on each roller on the equalization bracket. The only thing you can't see here is a ball screw lube that we put on. All right, when Scott's done with that, we'll clean up the workstation. He's going to go nadir over the lab to pick up on cables. Kjell's going to pick up the MPV, or non-propulsive vent, go zenith on node 3 to the port side in cone, where we're going to install the MPV. You'll see it here. It's a really tight area. We have the PMM that was relocated, removed, and there's a plate on it. It's removed for this video. I'll show you in just a second how tight the tolerances is. But we're going to move that first plate and then put the non-propulsive vent back on. Again, this is a very tight workspace. You can see here in the MBL video of how tight those 2 modules are actually going to be together. So we're using a lot of special tools to get that tied down when we get it in and installed. And Kjell's got the longest arm, so that's why we're sending him to the MPV. Moving Scott over the zenith of the lab over to the port side. He's going to run the forward cable that Kjell had temporarily stowed, run it the exact same way over the orange cable, and that's our power cable deployed back on the handrails getting ready for CBM, PMA move, and IDA install. Once we're done with that, we'll clean up the work sites and head back to the airlock. That's about a 6.5-hour EVA, and coming inside and getting ready for ARTS EVA in a week later. So I did bring a BLT or ball screw lubricating tool with me. We're going to actually entrap it into a crew lock bag lid, put grease on it, and then Scott will take it out and insert it into the latches for lubrication. So it is a probe with a couple of wire tie cradle added to it for strength. And the other big item we have is the AMS blanket. This is the 1G version. Onboard version will be completely white and not blue. You can see what Kjell has to take out when he goes. With that, I'd like to hand it over to Art and EVA 33.
Thanks, Grant. Hi, I'm Art Thompson. I will be the EVA officer for US EVA 33. In the development of this EVA, I've had the opportunity of working with an outstanding team. I'd like to thank Scott Ray, Reagan Cheney, and Paul Dumm for all the great work they've done in getting us ready to go out and perform this EVA. Now, as Mike mentioned earlier, the primary purpose of this EVA is to return the P6 cooling system back to its nominal configuration. In order to do that, we'll have the crew out at the P6 truss for the majority of the EVA, and we can break up the work that they're going to do into 4 major categories. So the first thing that they're going to do is reintegrate the P6 2B photovoltaic radiator. In order to do this, they're going to drive a bolt that opens a valve. It's going to allow ammonia to flow into this radiator again and cool the 2B electronic system. The next thing on the list is to isolate the 2 systems. So there's the photovoltaic thermal control system and the early external thermal control system, which are currently linked together. The ticker is part of that system. They're going to isolate those now that the nominal radiator is deployed. By isolating them, it does put us in a better posture in case we did get another leak. The systems are no longer tied together. The third thing they're going to do is retract the trailing thermal control radiator, as you see, called the ticker here, as we call it. We're going to do that because this radiator is no longer needed. We have the nominal radiator now in service for us. We're going to retract it. We're going to cinch it down, and then we'll put a protective thermal cover over it. That's going to protect it in the event that we ever need to use it again. The final thing that we'll do is to top off both ammonia systems. We do have enough ammonia in the systems to run now, but we want to have that extra margin in case we ever need it again in the future. In order to do that, we have a pipeline that runs from the P1 ammonia tank assembly all the way out to P6. Now, most of that pipeline is already in place, but there is a section that's about 20 feet long over the Sola Alpha rotary joint. And we can't really have that in place and still rotate the joint, so that's stowed on the P4 bulkhead. The crew will come out and install this jumper. Now, on each end of the jumper, we'll have a fluid quick disconnect that you see here. The fluid quick disconnect is going to be on each end, and when the crew comes out, they'll find it stowed on a dummy just like this. In order to remove it, they'll pull back on the release ring, and then they'll do an inspection real quick to make sure there's no debris or damage. They'll move it over to where the pipeline interface is. They'll plug it into the pipeline. And at this point, they'll see the forward band is visible. They'll know that they have a mechanical mate at this point. They'll pull on it to make sure that it's in place. And then to open the valve, they'll press the detent button, and they'll move the bail all the way forward. At that point, they'll see the aft band is visible, and this will mean that ammonia is now flowing through the system. Now, one reason I wanted to mention this to you guys, because you will hear a lot of talk between the ground IV and the crew on orbit about how to operate those QDs and some checks to make sure that everything is in the right configuration. We have had problems with these in the past. They can be finicky from time to time, and we want to make sure that we don't damage any hardware or create any new leaks. So you'll hear a lot of those checks. So I did mention the ground IV. Our ground IV will be Megan Bankin. She'll be walking the crew through the procedures step by step and keeping them on the timeline. On orbit, we have 3 crew members that will be working together. We have Kimia Yui. He will be the suit IV. He'll be helping Kjell and Scott get suited up and ready to go out the door for the EVA. Our crew members going out the door will be Kjell Lindgren. He'll be our EV1. He'll be wearing the suit with the red stripes, indicating he's the lead spacewalker. And then we have Scott Kelly wearing the suit with the white stripes, indicating that he will be EV2. You'll probably notice that these guys reversed roles between the two EVAs. This was so they both got experience in that lead spacewalker role. Now, Kjell and Scott have not seen this in the neutral buoyancy lab, but they have been reviewing procedures, videos, and briefing packages on board, so they'll be ready to go when it's time to execute this EVA. We have run this, though, in the neutral buoyancy lab with other crew members a few times. That's helped us determine that we have the right times in our procedures and the right call-outs for the crew to be successful on orbit, so that our procedures make sense to them and identify the right interfaces to work to. So with that, I think we have everything in place to have a successful EVA. I have a short video I'd like to roll now, and we can walk through some more of the details. For US EVA 33, both crew members will start out at the US joint airlock. We have Kjell here in the suit with the red stripes, and Scott will have the suit with the white stripes. Scott will bring out a crew lock bag that has all the tools from inside the space station that they'll need to use on this EVA. Kjell will pick out a vent tool bag that's on the zenith portion of the crew lock, and he'll take that out to the work site. From here, he'll head all the way out to P6, and he'll set up what we call a slingshot. It's a way to get the maximum length out of your tether. He'll translate out to P6, past the trailing thermal control radiator, the ticker. He'll stow the vent tool bag at this location. And this will be set up later in the EVA. And then he'll head over to the fluid quick disconnect coupler. Scott will be right behind him. They'll work together to remove a cover here, and then they'll drive a bolt which will open a valve and allow flow into the photovoltaic radiator that you see on the right side of this view. They'll work together to get the cover back on, and then Scott will head over to the P3, P4 jumper, and then Kjell will stay behind at this work site, and he'll break the connection, close the valves that link the photovoltaic thermal control system and the early external thermal control system. He'll then stow one of those jumpers to keep it protected for the future. Here we have Scott at the solar alpha rotary joint. He's going to install the jumper across the Sarge. This will complete the fill pipeline. And meanwhile, Kjell is going to start setting up the vent tool and vent tool extender. We want to have this set up because to make sure that it's in good working order before we begin the fill. We're going to need to vent the fill line to prevent overpressurization. So we don't want to lock that line up with ammonia in it. At this point, we'll be ready to start the fill. We have Scott over at the ammonia tank. He'll reposition a jumper, and that will route ammonia from the ammonia tank into the fill line. After a short leak check, as long as everything is successful there, we'll have Kjell mate the P5, P6 jumper over to P6, and this will start the fill of the early external thermal control system. From there, he'll head back over to the early ammonia servicer jumpers. He'll open a valve, and that will initiate the fill of the photovoltaic thermal control system. We expect this to take about 20 minutes. So while that fill is going on, we're going to have Kjell retract the trailing thermal control radiator. He'll be using a pistol grip tool, which is basically an EVA version of a cordless drill. He'll drive a bolt about 50 turns, and it'll retract the radiator. Once this is complete, we expect the fill to be finished as well. So Kjell will head back to the early ammonia servicer jumpers one last time. He'll close that connection between the two systems and stow them in a safe configuration and leave those two systems isolated. He'll then pick up the bags that Scott left behind there. He'll move them to a new location that's more convenient for this portion of the EVA. And then he'll head down to the P5, P6 jumper. He'll break that connection in the fill line and route that to the vent tool and vent tool extender. And this will begin the venting of the fill line. So you can see here the vent tool and vent tool extender. You see a cone showing where we expect to vent out the ammonia from the system. Here you can see some footage from STS-134 where Drew Feustel did the exact same task. They did a fill of this system as well. You can see he just opened the valve to the vent tool, and you'll see him look back over his shoulder, and you can see the venting of ammonia out of the system. So we expect to have a very similar view on US EVA 33. Expect that vent to take about 17 minutes to fully get all the ammonia out of the line. Meanwhile, we'll have Scott head over to the starboard CETA cart. He'll be reconfiguring this CETA cart so that we can take the mobile transporter to Worksite 1 and still rotate the Sarge. So he's going to fold over 2 brake handles and secure those with a tether. From there, he'll move over to the coupler. He'll remove that, and he'll attach it to the swing arm. And he'll drive 4 bolts to release the swing arm. And we'll now have the CETA cart in a good configuration to go to Worksite 1. He'll translate to the aft side of station near the ammonia tank where he was working earlier. And he'll stow that swing arm on a tool we call the Terra. Now, this is a tool we haven't really used at all in the past, but we finally found a use for it, a stowage location for this swing arm. So he'll stow it there, then both crew members will head back to the solar alpha rotary joint. Now, we've seen some vibrations in the data that we get down to the ground, and we think that's because there's a strut that's loose. So the crew members are going to both work and they're going to drive a bolt on 2 different struts. I think it'll just be a fraction of a turn, but hopefully that'll fix the vibration issue that we've seen. We'll then have Scott head forward. He'll remove the P3, P4 jumper across the Sarge. Once this is removed and stowed, we'll be able to rotate the solar alpha rotary joint again at the end of the EVA. Then Kjell will begin work on cleaning up the vent tool and vent tool extender. Again, all the ammonia has been vented out of these lines at this point. So he'll demate the P5 to P6 jumper from the vent tool. He'll stow that on a dummy, and then he'll begin coiling up the vent tool and vent tool extender. He'll pack that all back in its bag. This is a bag that remains outside because it has ammonia in it. We don't want to bring that back inside, so he'll move that back to the airlock at the end of the EVA. Now both crew members will meet up at the ticker, and they'll work together to install 6 cinches. So these cinches will compress the radiator, hold it into place, prevent it from being damaged. Here you can see on US EVA 7 the compression the crew needs to do in order to get a cinch installed. I think it's about 10 pounds of force to push down on that radiator. The crew will then work together to install a thermal cover over the ticker. This will protect it from extreme thermal environments. Here we see a crew member working in one of our NBL training sessions to get that thermal cover installed over the ticker. It's definitely something that it takes 2 people to do. There is another crew member in the top view here. So one guy Zenith, one guy Nader. Both crew members will pick up their respective bags and head back in to the airlock. Here we see Scott with the vent tool extender bag. He'll stow that on the Zenith portion of the airlock. Kjell will then, on his way back in, reconfigure the jumper at the ammonia tank. He'll move it to the vent position. In case we ever do get an overpressurization in the system, we have the ability to vent overboard if we ever needed to do that. Kjell will then translate back towards the airlock. He'll pick up Scott's tether at the slingshot location. He'll come back in on Scott's tether, and he'll have the 2 crew lock bags with him that are bundled together. He'll ingress the airlock, and that will conclude US EVA 33. That concludes my briefing. I'll turn it back over to the moderator.
All right, thanks, Art. So now we'll move into our questions section of today's briefing. We'll start off here in the room. A reminder, if you're on the phone bridge, press *1, or we're not going to see you in the queue and you won't get to ask your question. So be sure to do that now if you have one. So again, we'll start off here in the room. So why don't we start off right here in the front?
Robert Perlman with collectspace.com. Regarding putting the thermal cover on AMS, can someone remind me why a thermal cover is now needed, why it wasn't part of the original design of AMS to begin with, and how it was discovered that was going to be needed?
Yeah, I was talking to the AMS guys this morning. They are seeing a little bit of degradation. Pumps are working well. They're still maintaining. They want to get more life out of it. So we've got about, we were planning 3 years, we've got about 4.5 years with AMS. So they just want to protect it a little bit better. We have been using station to kind of shield it during high beta angles. So now we're putting the radiators up so we no longer have to point the targes to protect the AMS. So they're just seeing a small amount of degradation in the pumps, and they want to ensure a longer life out of it.
And a follow-up for the second EVA, given that they are working in and around ammonia-filled lines, will you have to reserve time in the EVA for a bake-out at the end of the EVA before they come inside?
That's correct. So we have a bingo time built into our procedures, so we don't want to do ammonia ops after that time to protect for a bake-out. If they do get contaminated, there's a few different, I guess, degrees of contamination. There's an unlikely, a likely, and a confirmed, or an unlikely, suspected, and confirmed. So depending on how severe it is, it depends on how much we do to mitigate that. But at the very least, we do a bake-out if we see any ammonia near the crew, flakes near the crew. And then, if it is a suspected or confirmed, we have a test that we do in the airlock to make sure that we're not bringing any ammonia back in with us.
Mark?
Mark Carreau for Aviation Week and Space Technology for Kenneth Todd. I have some IDA questions, and first I want to make sure Dragon is the only way to get an IDA to the ISS now, as I understand it. You mentioned the possibility of January for a Dragon flight. Can you kind of go over which IDA will or won't go on that flight and the next flight? And then in a big picture sense, I'm just wondering if in your evaluation of the work ahead, if you've already impacted your desire to start operations by late 2017 with crew rotations, or is that something to be determined in the future?
Where we're at right now, Mark, we will launch what we term IDA number 2. IDA 1 was the one that we lost back in the summer on the Dragon. Today, the only way we can get an IDA to orbit is on the Dragon. We won't fly one on SpaceX 8. We'll fly it on SpaceX 9. And we'll do the appropriate EVAs in and around that flight to get what we term IDA number 2 on board. And we'll put that particular IDA on the front end of station on PMA number 2. So where that leaves us then is how do we get the redundant IDA up there, and when do we do that? Right now, we're in the process of trying to get that IDA built, manufactured. It's looking like probably spring of 2017, probably the April timeframe. And again, a lot of that's going to depend on where we end up with launch schedules out in that timeframe. But in terms of the hardware being ready to go, and today, if we had to match it based on our flight manifest, we'll fly it in the spring of 2017. In terms of our ability to support commercial crew vehicles, I think we feel very, very confident. We had a plan to try to be there by the end of this year, but some of those circumstances were a little bit beyond our control when we lost the hardware. But we will most definitely have one IDA in place here in relatively early 2016, and we'll have the remaining work out in front of us to go get PMA 3 moved from its current location over on the Node 3 port side over to the Node 2 Zenith. And at that point, then we'll take the IDA number 3, it's what we're calling that particular IDA, and install it there out in the spring of 2017. So I anticipate if the commercial crew guys continue on the schedule that they're on, that we'll be there, we'll be ready with 2 ports.
Do you have a follow-up, Mark, or was that it?
I do have a follow-up. It's for Grant. I guess I want to make sure I sort of understand the function of the cables you'll be extending this time. Is it communication and data? Or I just want to make sure how you characterize
The
it.
first cable we're laying down is power cables for IDA and PMA 3. The purple cable is a power cable. And if we were to get to it in the get-ahead, there is still a third cable in the bag that is 1553 command and data. So we're laying down the data, the power, and if able, we can put down the command and data 1553 bus.
And I guess I'm sorry, I tried to follow all this, but it is complicated. This will put those utilities at the second spot for an IDA, which is on node 2, and PMA3 will move over, and these utilities will be ready for it.
That's correct. All we're doing is routing the cables. Previous EVA has already routed some of the cables out there, and we're routing the second set of cables, the last 3. So they are just pre-staging them. We're plugging them in, so when that EVA happens to go and prep the PMA, the IDA, the cables will already be there ready to go.
Okay, it looks like we don't have anybody on the phone bridge yet. Again, if you're on there and you have a question, press *1. But we do have some questions that we've collected from social media, so we have a couple more minutes. Why don't we take a few?
All right, we have a question from Twitter. If installation isn't coming through or if there are issues, what is the upper limit to spacewalk in terms of duration? How long could they stay out there?
Go ahead, Art.
Okay.
Talk about consuming.
Yeah, so there are a lot of factors there. Usually the limiting consumable that we have is CO2 scrubbing capability. So the crew has a canister in their suit. There's a couple of different kinds we can use. One is a metal oxide called Medox. The other one is LiO, or lithium hydroxide. So the lithium hydroxide usually gives us a little more time, but and it also depends on the crew's metabolic rate. So we plan our EVAs to 6.5 hours, but we have seen them go as long as 8-9 hours. We don't plan for any of these EVAs to take that long, but sometimes we have that margin.
Thanks. Another one from Instagram. What preparation needs to be done in order for a spacewalk to happen?
I guess I'll take that one. So there's a lot of preparation. I suppose it depends on where you scope it. So I'll start with the big picture. I mean, first we got to decide what we're going to do, and in this case, we sort of put these together over the last 3 months, and then we turn it over to teams led by Grant and Art, and they'll work with a lot of astronauts here on the ground, divers, suit engineers, and support personnel to design the EVAs, get the details, work them out in the neutral buoyancy laboratory in the pool, and sort of get the choreography down and make sure that we can get to the point where we actually have a workable EVA that can fit in that 6.5 hours. We'll work with our engineering counterparts to get into a lot of details on what torque settings to use on the pistol grip tool, how many turns to run that, to like some of the valves that Art was talking about, to close, whether or not we're going to release ammonia. We go through all of those questions on the ground, and then these guys start putting together packages of training material for the crew. It's really kind of unique how we train the crew on orbit. We start with PowerPoint presentations. We got a really, but then we get into a really kind of remarkable tool that we have called DUG, which I forget what it stands for, but it was the graphics that you guys were seeing here that we're going through. The crew actually has that on board, and actually it's pretty neat. We put a projector screen up fairly recently in a projector so the crew can see it in fairly large format and kind of together work through the EVA, talk together about how they're going to do things, come up with a strategy. I often kind of term EVA, it's sort of like a combination of deep sea diving and mountain climbing, and there's a lot of moving parts between the crews and the suits, the machines that they're in. And so that sort of gets them ready for the task. And then a couple of weeks out, we start prepping the suits. We got these suits loaded up. We do things called loop scrubs, which make sure that we've got a good set of water in them. We did some maintenance. In particular, we had to change out some of the, this time around, we had to change out some of the umbilical lines that go from the airlock to the suits to provide them cooling water and oxygen and power while the crew is in the airlock. Then it moves up to what we did today, which is what's called an on-orbit fit verification. The crew actually, when they get into space, their spine can elongate a little bit, and we have a really good idea of what their suit adjustment should be on the ground. But we want to make sure that after they've adapted on orbit, that we don't, that we've got good fitting suits. If they're not well adjusted and fitting well, you can start doing things like putting pressure on the wrong points of the suit. which tends to be fatiguing, especially when you're getting out into the 4 and 5 hour point. So they're doing that, and we're also working procedure reviews. We had video conferences with the crew. We did one a couple of days ago. We got another one on Friday. Final thing we do is we try to give the crew about a half day off before they go EVA. EVA is a long day. They'll go ahead and execute the EVA and then have a half day off afterwards. So a lot of moving parts, both on orbit and on the ground, and a lot of folks involved to support these two guys and what they're going to do in 6.5 hours.
Thank you. We have one more from social media. This comes from Twitter. What do you anticipate will be the most challenging aspects of the spacewalks?
Maybe each one of you can handle that. One each.
You're first.
Yeah.
I'm first. The most difficult part is getting out the door. Once a crew gets out the door and gets settled down, EVAs seem to go fairly typical. But there's, like Mike was just saying, there's a long road to get there, to get in the suits and get out the door at depress. So getting out the door, the crew's constantly studying. So the whole build-up, I think, is the most complicated. Doing the task outside, although they're challenging, it's the final product. So to me, getting out the door is one of the most difficult.
Now for us, we do have a lot of tasks that are jam-packed into a single EVA. We have high confidence that it's going to fit. But I think really the biggest thing is just keeping things moving, and if we do run into any kind of unexpected issue, working through that quickly and finding a way to resolve the problem.
Thank you.
All right, well, that'll wrap it up for us today. I want to thank our briefers for joining me today and for all of the questions that came in from reporters and from social media. Just a reminder to check out both of these spacewalks. They're going to be live on NASA TV, and you can see all the latest updates and the times by heading over to our website at nasa.gov/station. Thanks for joining us. Have a great afternoon.